Hi class, we're in Unit 6, Lesson 11 today, using equations to solve problems. So here we're going to use tape diagrams, equations, and reasoning to solve problems. So we've done all this already in this unit and in previous units. Now we're tying it together. In class, if we were sitting together, we'd be sitting in our SLC groups for activity 3 specifically. Our key ideas / vocab, we were going to put this in our classwork for our intro, is to copy down this tape diagram and write down these example situations. So we have our diagram, how we put it into a table, and then kind of reviewing our y = kx equation. So Sam drank X ounces of milk, Jack drank 1/4 more than that. So you have a tape broken up into fours or quarters, and then Jack drank a quarter more, so then our new amount would be for Jack would cover this whole distance, where the original amount only covered that. You could put that in a table. Here's our mixed number, here's our decimal form, and of course here's our improper fraction. And if our constant proportionality is 1.25, we'd write that in for our k right there. And that was an example of an increase. Now we're going to do a decrease. So Sue ran X miles, Jan ran 1/5 less than that. So we have our whole tape diagram broken up into 5 boxes, and of course Jan ran 1/5 less than that, so she's only going to cover 4/5 of the original shape. And our fraction would be 4/5, or our decimal form would be 0.8, and we'd sub in k for 0.8 right there. And we just want to make sure that you remember using tables, tape diagrams specifically for today, balance hangers that we've used recently, and number lines to represent a story. Now as we come into 11.1, remember tape diagrams. We have this tape diagram provided for us up here. We need to write a story that could be represented by this tape diagram. And then number 2, we need to write an equation that could be represented by this tape diagram. So go ahead, pause this video right now, and give yourself a chance to answers 1 and 2. All right, now that you've given yourself a chance to write a story, the book actually gives us an example of a baker having 3 boxes. So that's where we have a box for each one of these, and he puts a cookie of A amount in each box. We don't know how much A represents, but then after that he realizes he has enough to give 2 more cookies per box, for a total of 24 cookies that he's handed out, and you could see the total represented right there. Now we could write this equation 2 ways. Anytime I have a certain number of boxes or x's or variables, I like to go ahead and say, hey, put that outside the parentheses, and then a plus 2 is what goes into each box, and then we had a total of 24. The other option is to distribute this and multiply 3 times a, and then 3 by 2, and you get 3a plus 6 equals 24, and that's if we distribute, of course. Now let's go ahead and move on to 11.2, at the fair. So there's going to be 3 scenarios here, 1, 2, and 3, where we break down items for the fair, such as invitations, putting together prize baskets, and buying tickets to the fair. Our first example is Tyler is making invitations for the fair. He has already made some of the invitations, and he wants to finish the rest of them within a week. He's trying to spread out the remaining work to make the same number of invitations each day. Tyler draws a tape diagram to represent the situation. We can see that tape diagram right here. We'll explain how each part of the situation is represented in Tyler's diagram. Well, we need to look at how many total invitations is Tyler trying to make. Well, we have 122, because we could see that right there. Then we look at how many invitations has he already made. Well, looking at this extra 66 right here, I'm going to say that he already made 66. And then how many days has he to finish the invitations? Well, if he wants to use a full calendar week, it should be 7 days, and we could check our X's here. 1, 2, 3, 4, 5, 6, 7, and that matches up. So he has 7 days to make those invitations. So part B is where I'm going to let you try to solve this first, but we're going to read over part B and C and D. How many invitations should Tyler make each day to finish his goal within a week? Explain or show your reasoning. Now part C is going to ask you, use Tyler's diagram to write an equation that represents the situation. Explain how each part of the situation is represented in your equation. So then we're going to look at his diagram again, write an actual equation, and solve it using your equation. All right, go ahead and give yourself a chance right there to solve parts B, C. All right, how many invitations should Tyler make each day to finish his goal within a week? Well, if he wants 122 invitations, he's already made 66, so we could subtract that. We get 56 remaining. Well, we have 7 days to make those 56, divide that by the 7 days, and we realize that he needs to make 8 invitations per day in order to get those done in time. That's one way of reasoning. We didn't put in an equation, we didn't use the golden rule of algebra, but we just reasoned through the information to find how many invitations he needed a day. Now down here in part C, we want to use Tyler's diagram to write an equation. Well, we want to set our equation to 122 because that's the number of invitations we want. We know that he's added 66 because he's already got those done, and there's 7 x's right here. So we could go 7x plus 66 equals 122. And I kind of just explained to you where each part of the equation came from. Now what we need to do is use our equation to solve and show how we solve for x. Well, this is pertaining to the golden rule of algebra, so I'm going to use the gold here. We want to keep our equation balanced, so the opposite of 66 is to subtract 66, and that leaves us with 7x equals 56. And lastly, we need to divide it by 7 days to find how many he needs to make each day, and 56 divided by 7 gives us x equals 8. So 8 invitations a day. Number 2, we have Noah and his sister are making prizes for a game at the fair. Noah's putting 7 pencil erasers in each bag. His sister is putting some number of stickers in those bags. After filling 3 of the bags, they have used 57 total items. So explain how the diagram represents the situation. That's A. And then B, Noah writes an equation. Do we agree or disagree with it? And lastly, C is how many stickers is Noah's sister putting in each prize bag? Explain or show your reasoning. So go ahead, pause the video right here, give yourself a chance to work through it. Now that you've had a chance to go ahead and try to explain this diagram, agree or disagree with Noah, and figure out how many stickers Noah's sister is putting in each bag, let's go ahead and check our answers. So explain how the diagram represents the situation. Well, if there's 3 bags, we could technically break each bag or this tape diagram into 3 boxes right here. We have x plus 7 going into each box, and we used a total of 57 items, but of course there was 3 bags. So the 57 is our total. The boxes here represent the 3 right there, and then x plus 7 gives us this right there. Now Noah writes the equation 3x plus 7 equals 57. Well, that matches up identically to what we wrote down right here to represent the situation. Do we agree or disagree? Well, I'm going to agree because that's how I did it. Now some of you could have distributed and gotten 3x plus 21 equals 57, and you could say you disagree with Noah. That's okay, but understanding that these both represent the same thing, or to a certain extent represent each other, that's what we want you to realize if you did write that. We want to talk about the 3 bags, the x plus 7 items in each bag, and 57 total items. Now lastly, we need to try to solve for x, and we want to use our equation. So we have 3x plus 21 equals 57. We subtract 21 from both sides. We get 3x equals 36. Well, divide both sides by 3, and you get x equals 12. So Noah's sister is putting 12 stickers in each bag right there. Lastly, we have a family of 6 is going to the fair. They have a coupon for $1.50 off each ticket if they pay $46.50 or $46.50 for all their tickets. How much does a ticket cost without a coupon? Explain or show your reasoning. If you get stuck, consider drawing a diagram or writing an equation. So here we have our tape diagram that I want you to draw out, and I want you to tell me also what your equation would be, kind of right in here, and then break it down for me what the 6 family members represent in your equation and how are they represented in the tape diagram, and then go ahead and tell me how much the original ticket would be without a discount. That would be like solving for x. All right, hopefully in your tape diagram you broke our box up into 6 pieces to represent the 6 family members, and each you need to set this total to $46.50. And then we want to look at each diagram or each box containing x minus 150 or x minus 1.5, because each ticket is off by $1.50. So you could have had something like that written in each of your 6 boxes to represent each family member. Now, if I wanted to write this as an equation, I would have my 6 family members, and then of course how much it cost me for each of my family members to go, which would be x minus $1.50, and then I need to set that equation to $46.50. Now, I already told you that my 6 family members right here answering this question are represented by the 6 boxes that I drew up in here, and then the 6 in my equation right here is outside the parentheses, and what goes inside cost of each family member. Now, how do I solve this? I could divide by 6 right away, or I could distribute it out, and since we haven't done a ton of distributing today, I'm going to go ahead and distribute it out to give us some good practice. So 6 times x is 6x, 6 times a negative 150 is 9, so 6x equals minus 9 equals $46.50. Now I need to add 9 to both sides, and I get 6x is equal to $55.50. Then I need to divide by 6 to represent the family members, and I find that x equals, I believe it is $9.25. And let me just double check here. Yep, $9.25. $9.25 is what we cost us to get a ticket without the discount. But once we got the discount, we subtracted $1.50 off of that. All right, so today 11.3 is a little different in the fact that we're not in class, we're not sitting in our SLC groups to be able to make our SLC videos. So I'm gonna read the equation, or read the situation to you, go over the equation, how to set it up, tell you what x equals, and if you have questions about it, feel free to send me a message, come in at a later time, or set up a Zoom meeting so that way we could review it for you. So at this time, we're going to look at Priya, Han, and Elena, are members of the running club at the school. So Priya was busy studying this week and ran 7 fewer miles than last week. She ran 9 times as far as Elena. this week, and Elena only ran 4 miles this week. So given that information, I know I need to start with 4 because that's what Elena ran. I know Priya ran 9 times that much and this week, and that gives me 36. So she ran 36 miles this week. Well, that doesn't answer how many miles that she ran last week, which is the question we're trying to answer right here. So we need to add 7 to that, and we find that Priya ran 43 miles last week. Now, Elena wrote the equation of 1/9 parentheses x minus 7 equals 4 to describe the situation. She solved the equation by multiplying each side by 9, then adding 7 to each side. How does her solution compare to the way you found? All right, so we need to compare how Elena's equation represented or compared to how we solved Priya's miles in the previous part A. Well, we both multiplied by 9, as you can see right here, and then we both added 7. However, Elena took it a step further and followed the golden rule of algebra and was able to keep a balanced equation. So let's take a look at that a little bit more in depth. 1/9 x minus 7 in parentheses equals to 4. She also set her equation to the number of miles that she ran this week. So we need to multiply by 9 because that's the inverse or reciprocal of 1/9. Those cross each other out. Well, 9 times 4 is 36. And now we could set x minus 7 to 36. Now the opposite of subtracting 7 is adding 7 to both sides. And we find that x equals 43 miles last week. Same thing, except Elena set it up in the equation for us, and it helped us keep a balanced equation. Now 2, 3, 4, and if you get a chance or you feel confident enough, go ahead and go on to number 5. Go ahead, read those, and try to write out how you would set up the equation and solve for x. And if you have any concerns about how to solve for x later on, go ahead and reach out and contact me. So go ahead. All right, and number 2, one day last week, 6 teachers joined 5/7 of the members of the running club in an after-school run. Priya counted that 31 people were running that day. How many members does a running club have? Well, I know some of you would look at this and be like, well, they got 7 and only 5 of them showed up. But that doesn't help us get to 31 people because we added 6 teachers and we had a total of 31 people. So we had to go 5/7 of our total club showed up, and X is represented by the total number of people in our club. So when we break this down, we find out that there are 35 members in our running club at school, and you'd have to do the opposite by subtracting 6 from both sides. Once you do that, you'll find a number. Once you do that, you could use the reciprocal to multiply both sides to find x. And x should equal 35. And if you didn't want to do that, you could go ahead and do keep, change, flip. I'll cover the next 2. All right, in our third scenario, we have Priya and Han plan a fundraiser for the running club. They begin with a balance of negative $80. So they're $80 in debt because of expenses. In the first hour of the fundraiser, they collect equal donations from 9 parents. So we have 9x because we don't know how much each parent donated, but we know they all donated the same because they were equal collections. Now, their balance after the collections, or the 9 donations, was negative $44. How much did each parent give? Well, you should have to do the opposite of subtracting $80 in debt, so you'd have to add 80 to both sides, and then you'd have to divide that number by the 9 parents that donated, and you would find that x equals $4. Number 4, the running club uses the money they raised to pay for a trip to a canyon. At one point, the running club in the canyon, or during running in the canyon, the students are at an elevation of 128 feet. After descending at a rate of 50 feet per minute, they reach an elevation of negative 472 feet. So we know they started off somewhere at 128 feet. They descended at 50 feet per minute. So we don't know exactly how long it's going to take them to get to their final elevation, which was negative 472 feet. Well, the opposite of adding 128 is to subtract it from our left side, do it to both sides. Then you'd have to divide that number by a negative 50 feet per minute because we're descending. That's why it's negative. And then you would find that they're going to actually take 12 minutes to go from 128 feet down to negative 472 feet. So it would be 12 minutes right here. Then our musician, for Are You Ready for More? He went to 3 local fairs to perform. At first, he doubled his money. So first, he doubled his money and then spent $30. Then the next time around, at the second fair, he tripled his money and spent $54. Well, we can't just write it as X because our money now is represented by this expression. So we'd have to go 3 times 2x minus 30, and we need to subtract another 54. Well, that seems like we could combine some like terms. So let's go ahead and combine them. So 3 times 2x is equal to 6x. And then 3 times negative 30 is negative 90. Minus 54 will give us negative 144 from those two right there. Then at the third fair, our buddy, he quadrupled his money and spent $72. Well, we can't just write 3x or 4x minus 72. We're going to have to use this because that's what our money is now represented by. So we have our third fair, and then we have to go 4 times 6x minus 144, and then we subtract another $72. Well, again, we need to combine some like terms. That gives us 24x. This gives us a little over, what is that, negative 576 minus 72. So that's going to give us negative 648. And then we need to set our equation to $48, of course. And then we need to do the opposite, so we'd add the 648 to both sides. Then we'd have to divide both sides by 24. And then x would equal $29. So now here as we go through, I want you to read our lesson summary and then do our lesson synthesis. It asks you 3 questions. What strategies have you learned so far in this unit? What kinds of problems can you solve that you weren't able to previously? And then one thing you still have questions or confusions about. Take a second, go ahead and answer those. All right, what strategies have we learned so far in this unit? I know that previously we worked on dividing or distributing first, dealing with problems with the parentheses or equations with parentheses. And I apologize for my sloppy handwriting, but we've also used tape diagrams, and then we've also used balanced hangers. And then problems that you could solve now that you weren't able to previously, I would say equations with parentheses. All right, and then one thing, this is just going to be your choice, whatever you want to put right there. And then let's go ahead and look at our cool down. Diego scored 9 points, less than Andre, and in a basketball game. Noah scored twice as many points as Diego. If Noah scored 10 points, I apologize. How many points did Andre score? go ahead, pause the video right here, and do your best to solve for the points that Andre scored. Now that you've given yourself a chance, Diego scored 9 less points than Andre. Well, we're going to represent Andre with X, and we're going to subtract 9 from that. And then Noah scored twice as many points as Diego. Well, 2 times X minus 9, and we're going to set that equal to 10 because that's how many points Noah actually did score. We need to either distribute or divide first. Your choice. I'm going to divide first in this scenario. Divide by 2 on both sides. Crosses that out. I could drop down my X minus 9 now, and I get that is set to 5. And then I need to do the opposite of subtracting 9, which is to add 9 to both sides. It isolates X for us, and we find out that Andre scored 14 points. So go ahead, review our lesson, make sure your classwork is set up good, and that you have our cool down, our lesson synthesis, and our intro notes that we started off with, and turn that in for me. And then go ahead, jump on to your homework and do the best you can. If you have questions, try to go ahead and look at Mr. Morgan's homework help. And if you still have questions in addition to that, we'll try to chat about it in class or our Zoom meeting on Tuesdays and Thursdays, and it'll be due as soon as we could get it done. Thank you.